Us to speak to you today about the benefits of geospatial engineering. So what is geospatial engineering? Geospatial engineering is really a whole host of options that are available through engineering using GIS platforms such as Esri's ArcGIS, several other GIS-based tools. In this conversation, I'm going to talk to you a little bit about some of the tools that are available using Esri's ArcGIS in the Esri ecosystem. So it's really the ability to complete your engineering and into construction phase using geospatial data such as available parcel data, demographics data, putting your GPS accurate locations, your geospatially accurate locations into a web-based system, and having that true to life 100% scale drawings and maps available at your fingertips and the fingertips of your maintenance techs out in the fields. So leveraging geospatial data such as parcel data, demographics, to determine median household incomes, where you want to target your marketing, being able to see age demographics in that area to see what type of marketing campaign might be most effective. So some of those different types of data is really helpful in that geospatial engineering aspect and in that marketing phase for a lot of you folks who are owner operators. Being able to have automation and an advanced quality control using the intelligence and the automation that's built into the system has really been a game changer for us here at CHR, but it also benefits our clients in many other ways that we'll kind of touch on as we summarize and as you guys kind of see the effects of the geospatial engineering and what we're kind of looking at here. So on the next slide here, I want to talk to you about one aspect that kind of fills in the blanks of that data that you might possibly be getting from your county assessor on parcel data or roofline data, and that's going to be custom imagery sources. This fills in the gap. On parcel data and other data sources, typically these counties or municipalities are going to update that data maybe once a year if you're lucky, twice a year. But for the most part, that's once a year. And we're getting some echo here. I'm just going to make sure everybody's muted. Okay. Ooh, I can't. Scott, can you mute everybody?
Gotta make sure. Yeah.
I'll continue on. So leveraging that GIS, or sorry, that custom imagery source is going to fill in the gaps of that GIS data that might be just a little bit outdated. So you can get real-time, up-to-date imagery that is going to help you spot that new subdivision or that new house that got put in here between the dates that geospatial data was updated and now. So you can see that location, you can plan a route to it, and you can account for that in your passings count. So there's several different imagery sources that are available to you. Drone imagery, your fixed wing, which would be your airplane or even into a fixed wing drone, but typically that would be in the airplane mode. Your street view, which is going to be a vehicle mounted, backpack mounted, person mounted camera that you can walk a path or drive a path and get that street level imagery. And then you've got that satellite providers, and there's some commercial examples here that I'll list out here, like Near Maps, which is they typically fly in urban, densely populated areas, and they have relatively accurate and high quality information. And then you're going to have your satellite imagery, such as like a Black Sky, who's a provider that you can put in certain parameters, is, you know, under 30% cloud cover, put in your time of year so you don't have tree cover and things like that, and they'll go out and they'll provide you that imagery, and that can be done anywhere that satellite has coverage, which for our example is going to be most of North America. And then you have LiDAR sources that you can fly with helicopters, airplanes, drones, vehicle mounted. There's all sorts of different ways that you can get LiDAR. These range in custability and how expensive they are quite dramatically. So a drone imagery, which is what we're looking at here, and this is actually in Michigan. This imagery is one of a small town in central Michigan. You, depending on the resolution of your camera and the altitude at which you fly, you could get down to read the sewer manhole, say sewer on the top of it. It just depends on the quality of the camera and the altitude which you fly. This drone imagery was gathered with a relatively inexpensive drone, roughly $5,000 to $6,000, and we flew at an altitude of about 300 feet. And you can't quite read sewer on the top of that manhole, but you can get pretty close. You can see extensive detail, which is about 50 times higher resolution than a Google Earth or Bing Maps or whatever type of imagery sources that's commercially available. So highly customizable in your drone flight. As I zoom back out, you can see we carved pieces of the town out, and you can get super customizable as far as your drone imagery. Fixed wing flights, less customizable, because you're flying with a camera at 8,000 to 9,000 feet, and you're going to get huge, large swaths, but you're going to get a bunch of data that you weren't necessarily expecting, or it's not as limited and as customizable. And you're obviously on their time, on the pilot's time, versus a drone where you can go out, if you guys are commercially certified, you can go out and capture your own imagery and 100% customizable. Street view is very customizable as well, unless you're going through, like a Google Earth imagery source, which is still Street View. But obviously that's not customizable to your routes, and the quality is quite poor. Your Street View imagery can get super detailed if you have a good high quality camera. A real high quality camera is about 15,000, and 10K video, 10K stills, which is 100 times clearer, right? So this level of detail really helps you fill in the gaps and see all those roof lines, and you can actually start to make engineering decisions off of this, which is going to help you with your speed to market. Moving on to the next tab here. So I want to talk to you a little bit about web tools. So web tools are mapping data that add some kind of functionality to it that might have been manual pre-GIS. So batch processing of data. So you can import your make-ready engineering spreadsheets that come from a pole owner. You can load, if you have a tie point between your pole data and their pole data, you can assimilate that data right in with a push of a button, move that spreadsheet in, and now you have your updated costs of each pole, what the status of that pole is, what make ready is on that pole, for example. So that kind of takes care of your data entry and batch processing. You really can get rid of a spreadsheet if you can format your web tools and the data properly. You're no longer living your life with a spreadsheet, which is what you're missing with a spreadsheet is location. Too many times in the past, even 5 years ago, I was looking at spreadsheets determining if we were going to pay make ready in certain areas and having to look at a spreadsheet, and then I'm having to swivel chair over to a different map trying to find that pole ID of their spreadsheet to my pole ID, and then saying, well, this pole's $5,000, but then the second I turn back to the other screen, I can't see that pole is $5,000 and the one next to it's $10,000. And then to make those determinations, well, I should just do a buried dip here. So I want to kind of scroll in here a little bit to the data. And there's a little bit of a legend here I just kind of want to pop up for you real quick, so you can see the different types of make ready that is on each pole, if poles need to be changed out, if we're going to reject those poles, and if we're going to bury them. Just wanted to throw that up there real quick so we can kind of see what we're talking about here. So in this case, I'm going to do a batch attribute editor, and this is helpful for areas that have multiple poles that all have the same type of attribute. So in this case here, the make ready came back, and in this case, all of this was power make ready. I quickly made the change. These are all now tagged with power, and then I can go into the individual level. This pole here, the estimated cost was $10,000. Let's just say it came back and it was $13,500, and it calls out for a pole change out. We say yes, and I just kind of got to move that imagery back out so it updates the tile, and you can see now that that symbology has changed, highlighting a pole change out. Let's move to these two poles right here. The estimated cost came back at 9,000, and let's just say the actual cost ended up being 5,000 a pole. We didn't have to change those out, but we had two COM, and this was combo of power and telephone make ready. Symbology's changed. Now that data is tied in, and really where this is going to come into effect and really shine for us is on the next slide where we talk about dashboards. But we'll get to that here in a minute, as that'll summarize this data that we're doing right here. So we have the ability in these maps here to filter based on type of poles. So if I zoom out just a little bit, you'll see I've got different symbologies. And as we showed that legend a little bit earlier, let me just look at all poles that are power, right? It filtered all the poles out of the map unless they're power poles. And now I can look at, okay, I've got huge runs of power poles here. You know, maybe my time frame for the project isn't going to support having to do this many poles of power make ready. I better, you know, start to look at a underground application. You know, you can start to get granular in the level of detail and start to become proactive rather than reactive. You know, you also have the ability to look at tabular data. So that, I mean, here's your spreadsheet. It's just going to be in GIS format, giving me location data. We also have that ability to tie that into the maps as well. Also, we can start to summarize data. So I'm going to just select that, and then I can start to see on my infographic tab that I've got 418 strand feet selected. You can customize these infographics to say the number of poles, to say the number of poles that are COM and power make ready. Right? A lot of this is customizable and really what your needs are. So the web tools really help with mass data entry, being able to get that visual, and it replaces that spreadsheet data. Whereas once I put it into the spreadsheet, it's dead data. This data here is live data. It's in a single source of truth that I can use for permitting, design, construction, and so on. So I'll move on to the next tab here. So I want to talk about dashboards a little bit and summarizing this data. So the data that we entered and manipulated on that last slide is going to be summarized here. So this is that same data, but now I have this roll-up summary that I can start to make better decisions with. So I can see at a glance here, and I'm going to pop this out here in a second, but I want to give everybody a chance to kind of look at the, you know, what dashboards, the benefits of those are. You know, the big one here for me is you can become proactive instead of reactive, and you can start to predict cost overruns if you have financial data tied to it. Those are the couple of real big takeaways that might be interesting for folks on this call. You can customize this however you'd like to see. Dashboards are an out-of-the-box solution from Esri in this example using GIS, and you can just start to customize to your own needs. But I'm going to pop this out real quick just so it's a little bit easier for everybody to see. So now that that's popped out to just a little bit larger size for everybody, we can start to zoom in and we can see that same symbology that we had updated in our map on that last slide, but I can start to summarize that data. So I'm going to come up here and look at the FDH boundary of 04, which is the boundary that we were manipulating earlier. It starts to summarize those poles, and you can see, if you remember, this one pole right here, we called out to be a change out. So it's going to flag that for me, and we can see that in this area, my estimated cost was about 30,000, and it ended up coming in a lot under our estimated cost at 23,500. So we can start to summarize that data. We can see that in this application, there's 4,600 strand feet. As I said, you can customize. You can start to add in cost per pole, cost per foot. You can get down to that level to give the decision makers the ability to really understand their plant and make better business decisions. Okay, we need to go buried here. We need to get rid of this area altogether. It's too much power make ready in this case, right? 67 poles. This is pretty heavy into the power make ready. A couple poles only have COM make ready on them. And then I'm gonna go ahead and pan out of that real quick. I want to show you up here, you can see the make ready engineering breakout. So COM make ready makes up for 10% of my design right now in its current state and 35% of its power. Well, I can see here, I haven't got make ready back on 708 poles. So I don't know what's going to come out of those, but I know I have 680 feet, or sorry, 680 poles. I can filter down the same as I could on that other map. And now it's just going to show me the 680 power make ready poles. I can get that visual. I can see that red halo in the background. Those are pole changeouts, and you can see I have 5 of them. And we'll pan into this area here in a minute. But I can start to filter down. Okay, these are important poles to me. 308 poles of no make ready. That means I can go build, right? We can get to work in these areas. So that's an important one to be able to understand that, right? So I'm not going to have any cost on those for make ready, and that's great to know. So you can also tie in like your application fees and costs to start to filter down and understand what each application is costing us per pole. So I can again filter down into the application level. So we looked at the FDH level earlier. Here's all the poles that are on the application for this area. If I reset that, and then I'm going to go back over to FDH 06. And now I can start to see, we estimated that it was going to be $41,000 in cost, but now its actual cost is $90,000. Well, why is that? Well, I've got 4 pole changeouts. Those are going to be high dollar poles. I can click into my pole and I can start to get some of that data. Okay, you know, here's the actual cost that's coming in on those, right? So I can still have all that tabular type data living in my map, but I got that visual that goes with it. So I can make that call here to say, well, I'm just going to bury this road right here. I don't have to get on these poles. We can get rid of those change out. And then so we can go back to that previous map that we looked at. We can put these into a rejected pole state. We're not gonna accept the make ready, and then we can plan a buried route through there. So we're making better business decisions because we have that financial data tied with the graphics, able to help me make better decisions. I'm gonna go back to this guy here. So, you know, those are some of the benefits that we talked about using geospatial engineering. The big 3 on this slide for me, the biggest impacts, the hardest hitters for you is going to be the single source of truth, being able to have one system of record that's going to allow me to work permitting, design, construction, all at one time in a linear fashion where everybody can work on the same data. We don't have dead data tied to a CAD map. And the second I download that and work on it on my desktop, that data is outdated. That no longer exists, and we're now working in that single source of truth. The ability to become proactive versus reactive. So much of the work that we do in the telecommunications industry is as a result of having to react to an issue or a challenge that has already happened. In this case, when we start to use the dashboards and the different analysis tools that are available within GIS, we can now start to become proactive and head problems off, solve problems before they ever become one. So that's a very important one. And then the ability to improve your speed to market, because I'm able now to work on design at the same time I'm doing permitting. I've sped up my workflow. The old method where design had to be done and then we went to permitting. Well, permitting is going to be your longest lead time effort in your entire workflow. I can condense that because now I'm able to work that during design. So let's just say a design took me 3 weeks. That's 3 weeks that I've already got done with permitting, and it's sitting with the agencies now. And they're now able to approve that 3 weeks sooner because I was able to work that in conjunction with that design. So those are kind of the big 3. You know, secondary benefit is going to be real-time updates to and from your field teams. So if you have maintenance crews, service techs out in the field, you can push live data to their tablet device, and they're now able to get routed to a service call without having to pick up the CB and figure out who's closest. And you can have vehicle tracking, asset tracking, and see that. You don't even have to call somebody, you know who's closest to that trouble ticket. So those are going to be your benefits to the geospatial engineering and the geospatial ecosystem. It's really that improved speed to market for your projects to start generating revenue quicker, which is going to be the heaviest hitter on this list. So that was kind of a real brief summary of geospatial engineering as a whole, and some of the different tools and technologies that are available. And I wanted to make available myself. Here's my email and my phone number. If you guys have any questions, absolutely reach out, and we're gonna have a little Q&A session here. I'll turn my camera on, and if you guys have any questions, we can talk about it. Anybody have
Dustin, hi, this is Scott. We usually have a pretty quiet group. So, are there any questions from those of you who are on the call now or on the webinar?
No, I'm good. Thank you.
Dustin, do you have anything else to wrap up, or?
No, I appreciate the opportunity with the Telecommunications Association of Michigan and being able to speak to everybody today. I appreciate it. Thank you.
Thank you very much, Dustin. Thanks for those of you who are on the call. You've got Dustin's contact information if you need or want to reach out to him. So thanks, everybody. Have a great day.
Thank you.